All right, at the end of the part one podcast, I had the routers configured in the way the book recommended, and it worked as expected when I took down the entire router. But what happens if the entire router doesn't go down? And first off, let me start a ping over here. Make sure that works. What was it? 101.10. All right, we have our ping going. We have two routers in place, so if one of them becomes unhealthy, which means it's not routing traffic, we want it to not be the router that's being used. So in order to force this router to become unhealthy, we're going to change the switch port to down by turning it off. And now if we look, my ping broke. But hey, wait a minute, shouldn't the other router have taken over? And yeah, the answer is yes, the other router should have taken over. And if we look at this, this router still thinks it's active on both interfaces, so that's kind of a problem. And if we look at this other router, you look at the debug message there, it's became active on one of the interfaces. It's active on gig 01, so on the other side of the network, this router thinks it's active, but on this side of the network, this router thinks it's active. So that's clearly a problem. And there's some additional commands we can configure to make that not happen. But first thing, we're going to go off on a little tangent. So I'm going to turn this interface back on. And in theory, this router should take back over as the boss and everything should work fine. So if I look over here, I see, hey, the router interface is back on. What's the problem? Why am I still dropping pings? Well, the problem is this little orange light. Remember we talked about spanning tree before, and it takes 50 seconds to become active. Well, if our router interfaces are connected to a switch port, we almost always want to enable port fast on those interfaces. What the heck, man? I'm having trouble typing. Int range GI. There we go. So we always want to have port fast on our router interfaces. So if we look, the interface should go green. We're back up. Let's go ahead and do that little example again where I take the interface down. I take it down, it's down, my pings are failing. Now if I bring the interface back up, it should come back up. The ping should come back up much quickly. So we see no orange light. I have link. Everything's good. And let's see about my pings if they come back up more quickly. Which, there we go. The pings were up much more quickly. Instead of the 50 seconds of downtime, then the port fast enabled, the router interface comes back up much more quickly, and our pings start working much more quickly. So that's just a little real-world tip for you. Plug your routers and firewalls into ports that are enabled for port fast, because there's no reason to be waiting for spanning tree if you don't have a switch plugged in. So now we're back from our little tangent. That behavior is clearly bad, where this interface going down does not cause this router to fail. So I do have another packet tracer file. I've already worked on this and got it working. So we'll open this other file. In this other file, I have the link down, so I'll go ahead and bring that back up so everything gets into the normal state before we start. In this other file, I've done some additional commands on my routers. So if we go look at what I've done, under each interface, I've added a track command. So essentially, this tells this interface to watch the other interface, and if the other interface has a change of state or stops working, then it should decrement its priority. So if we remember, the one that has the highest priority is the winner and is the boss. So the priority is set to 110. This command says, hey, if gigabit 01 goes down, I want you to decrement my priority. The default value is 10, so it's going to change this guy's priority to 100. The track command, as listed in the Cisco documentation, has a number out here at the end you can put to tell it how much to decrement the priority by. The default is 10. and the simulator does not allow us to put a number out there. So in that case, I believe it's going to decrement it by 10. I've also put this preempt command in there that says basically if you have a higher priority than your other standby routers, then you can take over as the new standby router. So those are the two changes I made to this router to support proper operation. I did have to make those same changes to this other router, but then I also had to make an additional change. If we look over here, I have the same two changes, the preempt and the track commands, but I also changed the priority on this router to 105. I did that because the priority on the other router is 110. The default priority for HSRP is 100. This router initially did not have a priority command, so if you take 110 and subtract 10, which was the default value to decrement the priority by for the track command, you end up with 100. So if both routers have 100, I'm not sure how they handle a tie, and a tie is generally a bad idea in that case, because if one router is decrementing the priority, it clearly should not be in consideration for being in charge. So I made the priority 105. So now, in theory, if I take the other interface down, start my ping. In theory, if I take the other interface down, get this ping going. In theory, if I take this interface down now, then I should have this router active on both interfaces. It's listening, which is one of the transitional states to becoming active. Oh, that was router 1, sorry. Router 1 is the one that's going down. So it was router 2 is the one that should take over. So let's look at router 2. If we look now, router 2 is active for both standby groups with a priority of 105. And router 1 shows active for the interface that's down, which we don't care about really because the interface is down. And it shows standby for the interface that's up. So if we look back over here at the ping is working. So while our book goes through those initial commands, here, why don't we bring this interface back up and make sure it switches back as expected. While the book went through those initial commands for configuring HSRP, and those are some commands. I thought I turned on port fast. What the heck? Could have swore I already did that. So anyway, while the book went over those initial commands that are a incomplete and sometimes working HSRP configuration, I thought it was important for me to go over the full weight of what you need to do with HSRP. One other thing I'll point out, I guess, what happens if you have a third interface? We have a third interface, so I'll go ahead and connect it. What happens if you have a third interface connected to a switch? Right, so we have this third interface connected. Now in our config, we're going to want to configure a standby group for this interface. We'll do all the IP address, everything. But now on these other interfaces, now on this interface, I'm going to want to track gigabit 01 and 02. And on this interface, I'm going to want to track 00 and 02. And on 02, I'm going to want to track both of the other interfaces, 00 and 01. So that way I'm looking at all the interfaces, and if any of the other interfaces go down, then I take a HSRP action to lower my priority so that the other still working router can take over. I'm not going to configure that, but that's what we would do if we had more than two interfaces. So that is a follow-up to the initial. Here's how the book tells you to do HSRP that I think contains some extra information that's valuable.